looking at that guided example. You have it in. Are you putting the numbers in now, Rita?
I had it in, but then it didn't save.
Oh, you put it in? Did you write down the equation that you got? Okay. Maybe set up an account down Desmos. I would do that. Then it's real easy to say. You just have to make sure you put titles. Otherwise they all come up untitled. We don't want that. So I guess I'm gonna move forward with it. We're not gonna wait to redo it and everything. If you guys are having difficulty when you're doing it at night, you can email me. You can call one another and get help. You can just come in after school and work on stuff. Get started on your work so you know that you can. Somehow or another we gotta find a way to become more independent if we're gonna, go through more material. But if we drag like this, then we're gonna have a lot of stuff to finish up next year. It'd be nice to be able to move forward with it. Did you get it in?
Mm-hmm.
Did you do the regression?
Like,
So the regression is coming up with the equation. So when you're in Desmos with that regression, you have to copy and paste the y sub 1, or whatever it is. If you have several equations like we did yesterday, we had 2 of them. And, you have to copy the appropriate. And then you use that squiggle, because that means it's going to do a regression. So what do they mean by a regression? See, regress is to work backwards. So if you have this set of points like this, and then you work back to get a line, or work backwards to get an equation, that's doing a regression. Normally what we might do is have some equation that we're given, and then we plot the graph with points. But here we already have the points, so we go back and figure out what the equation was. That's why they call it a regression. So then our form is going to be b, g, and then you do raised to, and then you do x sub 1. And it kicks it out. So what did you get? What would your equation be?
equation line, I got y equals 2.240 times 1.218 to the power of x. So you can just substitute them.
That's what you got for that guided example.
Yeah.
What is this? This is the average speed of a computer in the year it was made? Okay. What's the speed of a computer today? How fast of a processor are you guys running on yours? You know how to find that? Go to the Black Apple in About This Mac, and it'll say what your processor is right there. What? Gigahertz, GHz. You guys are using 1.6s? Mine's a 1.4. Is yours a quad core? What does it say after 1.6 gigahertz?
Intel Core.
Intel Core i5.
Okay, so it's an Intel core, whereas this one's a quad core, so it's a 1.4, but it's even faster than your 1.6. But either way, so you have a 1.6 gigahertz. Let's just write that down. Hertzes are cycles per minute. So it cycles through processing the data. 1.6. What's giga?
Thank you.
Do you guys know? So you know what kilo is. Kilo is like a kilogram.
Oh, it's like, what's it, 1,000?
It's 1,000. It's 10 to the third. So what's mega? You got the computer, Google it real quick, mega. What's mega? I don't wanna get them wrong, you guys tell me, what's mega?
It's
10 to the 6th, which is a million. So that's 10 to the 6th. Kilo's 10 to the 3rd. What's giga? What do you think it is? 10 to the 9th. So that's a billion. So this is 1.6 billion hertz. And what are the numbers on this table here? These are in megahertz, aren't they? In the year 2000, it's 420 megahertz. So in the year 2000, at 420 megahertz, that would be like 0.4 gigahertz, 0.4. So your processor is 4 times as fast as the year 2000. So you have your graph? You have everything there? Can we use your computer? Bring it up here, let's plug it in.
connected to the notifications for my phone.
Can't hear you.
It's connected to the notifications for my phone. And I can turn off
What's it connected to?
the notifications on my phone.
So, I'm not gonna suck the data out of it. Can you put it on there? Yeah, I mean, we're not gonna bring up your phone. Won't bring up anything but this. You'll see. Is there an HDMI on these or not? No. No HDMI, so. We'll go with one of these. So here you are. That's yours. I'm gonna make this so we can see it better by putting it on projector mode. Okay, there it is. And then we're gonna bring up your equation. So there's your equation. So your equation is, the B is 0.07. Your B was 2.24?
Yeah.
Really? And her G is 1.4, yours is 1.2. Okay, I'll buy that. This is confusing though. 0.071 times 1.43 to the x is what Desmos says. I mean, Desmos doesn't make a mistake. When you worked with a computer, you had to do a regression. You had to enter your data, you had to do a regression, and then you had to write it down and plug it back in. If we looked at these numbers here, can you guys glance at them? Are they correct? Are they what are given in the textbook? So they count by tens? And you started with year 0 at 1976, yeah? 2, 4, 5, 8, 13, 16, 20, 35, 48. So those are accurate. See, this is so far off, Trenton.
No, when I looked in the back of the books, I didn't believe it, but it was right.
What does it say in the back of the book?
In the back of the book, for example, a 2.241 times 1.218 to the power of x.
Really? Wonder why this is so much different. I'm puzzled. I'm puzzled why that is so much different. It must have a different algorithm that it does. But either way, let's take it. Let's ride with. Let's do something with Desmos, and let's do something with. This is the TI-84. what year is it?
Now, back then.
2021, right now, right?
2021.
So your computer's a couple years old, isn't it? Does it say on there how old yours is? Is it 2017? Okay, so if it's a 2017, yeah, mine's a 2019. So if yours is 2017, how many years after 1976 is that?
Just minus the year.
How many years is this? Can you figure that out? What I want to do is figure out what that line would predict your computer to have for its processing speed. How many years has it been at 2017 since 76?
And then just go down 3, just 41, plus
41.
1. This is 44.
So that means if you had an x value of 41 in here, we could have, these are megahertz. So 1.6 gigahertz, you gotta move the decimal point to the right 6 places. It would, or 3 places. So that would be 1,600 megahertz. This is the year 2017. So take this equation here and use it to figure out the processing speed that this equation says we would expect in the year 2017. Do that. So we have, this is the data, the line is the model that we use as a prediction. You're punching away on your calculator. How do you figure this out?
You just plug in 41 to the x.
Plug in 41 to the x. So y is equal to 0.071 times 1.43 to the 41st power. What do you get?
I got 165,972.4041.
Okay, let's just stop right there. That's what you get from the Desmos graph. So in other words, this is how many megahertz we would be predicting for the year 2017 if this trend continued. Is that anywhere near this? Is this number anywhere near this number? Well, this is 1,600. This is 165,000. And this is what? 100 times bigger than this? 100 times bigger. So clearly this trend has not continued, has it? No. So okay, that's according to this. Let's use this one. So this is according to Desmos. So now let's use the TI-84. 1.218 to the 41st power. What does that predict? I bet that's going to be closer.
Power of 41.
Yep, to the 41st power again.
Yeah, it's closer.
What is it?
It's 7,274.22.
Okay, we don't need the decimals. Whole are fine. So it's this many megahertz. That's still, what, like 4 times as big? So clearly things have flattened out. And so if you follow this graph, if we went all the way over to where it's 41, and we look for that number, it's gonna be so far off of the graph. It's almost straight up. So what has happened, I guess the judgment from this and the statement we can make is that during the 1970s and 80s, technology was booming. The development of the computer processors was making it so that they were becoming faster and faster and faster, but then all of a sudden they got to a limit of how fast they can make this stuff happen. And there is a limit, because it's all electricity moving. And you can only make electricity move through things and cause things to happen so fast. So what they've done is like this. This is a 1.4, yours is a 1.6, but this is way faster. Because what they've done is they've made it more complex. The way it's a quad core, so there's 4 things happening in here at one time instead of one. So instead of having like one really strong horse, they got 2 not quite so strong horses, but together they move things faster. It's kind of like that. So anyway, there's a regression. Whether you use Desmos or use a TI-84, that's interesting. I don't understand that. If the book said this number, Trent, then you did it right. Because the book is based upon, I know the algorithms of the TI-84. Don't know why that is. Maybe I'll talk to Mr. Davis. He knows a lot about this kind of stuff as well. So what do we have left? That's it before the actual assignment. So here we are, we're on page 421. Yeah, so the takeaways from this, you need to be able to take data from a table like this right here and run a regression with it, either with your TI-84 or with Desmos. And then you need to be able to interpret the results of it. And the interpretation is that the line is the predicted trend or the predicted model from the existing data. And the data points just guide what the line becomes. So if you were to change any one of these numbers, it's going to change where that line goes.
My points are not very good.
Than hers? I think it's because of the scale. What's the far right number for your scale right now? It's 25, right? So hers, what you saw up there only went over to 25. So make this 0 and make this like 30, and then you're going to find that it looks the same. See? Click outside it, you can see now. Okay. Do a regression. Did you do a regression? This needs to be changed to y sub 1 and copy and paste it from the table. And then it'll do a regression. What the heck? That's not even following the line. Oh, because you typed in 2.24, 1.43. So what you should do is make that B and make the 1.43 G. Let it decide what it's going to be. There. Yours is one. Is that? Yeah, it's kind of the same numbers, isn't it? Yeah. Hey, look, it's way underneath. Okay. Oh well, it is what it is. I don't understand why it comes out like that. So what you guys waiting for? The assignment? 1, 2, 3, 5, 7, 11, 18. 1, 2, 3, 5, 7, 11, 18.
1, 2, 3, 5, 7, 11, 18.
Yeah, 1, 2, 3, 5, 7, 11, 18.
And what page?
3, 4.
Yeah, 421 is where this lesson is found, yeah. So tomorrow we have a quiz, then next week we're going to talk about something called function notation. Just a different way of writing equations.